us to embrace what we have been learning. Good evening, all, and welcome to today's class. So I'll be sharing my screen on the packet tracer activity we are trying to do the last time, and then probably we'll be taking everything up from there. So here is the packet tracer activity. I hope you can now see it in your screen. So the modalities still remain the same. If you are acknowledging to something I'm saying, I will be loving to get a thumbs up. Then in the scenario whereby you want us to attend to something later on, you will always use the comments or the chat box. Then certainly if you want to say something, interrupt us so that we'll get something straight, clarification, you can always raise up your hand and then I will allow you to speak. And that is so. As you can see, this is something we are trying to do the last time, and we have gotten to some extent. We have gotten to the point of connecting our television. As you can see, our television was connected, and it was showing viewers or thing like it was showing that it has been connected by showing us something is playing on our television. Okay, so then we are trying to, okay, we already connected our cable modem to our home router, wireless router. We connected our home wireless router to our office PC. We connected our home wireless router to a wired connection to our bedroom PC. So we have done most of those connections. So if we are proceeding through the instructions, we should be on the point whereby it's telling us how to configure the wireless router, which is the most important thing from the topic that we had on home router configuration. So I want to show you how to be able to set up a home router, though this is mostly for people who will be into networking. So with that being said, so let's follow the instruction of the part 2 of configuring a wireless router. So are you all with me on this? If you are, please can I get a thumbs up? If not, can I get you to raise up your hand so that we can address your concern? Okay, thank you very much for that. So it says from the instruction, we should click on the office PC. As you know, this is a system unit. Of course, when we are on the system on a physical thing, you know that you'll be using the monitor to do this on your mouse. So we'll click on the office PC and it provided us with, can you see the office PC? Can you see the office PC? If so, can I get a thumbs up? If you can see the office PC, that's the dialog box. Can I get a thumbs up? All right, thank you. I'm in the dialog box. Okay, thank you. So, from there you can see that the instruction says we should then click on desktop. We are clicking on the desktop tab. You can see the IP configuration, dial up terminal command. Is that so? I want to be sure you are seeing what is on my screen. I'm saying, are you seeing the IP configuration, dial up, terminal, command prompt, web browser? So you are seeing those things. Can somebody just
Please, I'm
open
not
up
seeing it though.
You are not
I
seeing
can't
it.
see it too. Me, I can't see it also.
Please, I'm not seeing it though.
That's what I was saying, and you guys are giving me thumbs up.
I can't see it.
You are giving me thumbs up where you are not seeing it.
Please, others, I can
All
see
right,
it.
let me
See
reach.
it, oh, sir. I can see it.
You can see it.
Yes, sir.
What can you see? Call out what you can see. Call
I
out
can
what
see
you
your
can.
cable. I can see your office PC.
No, that's not what I'm talking about. Sorry. You guys would have said earlier, and I thought that let me share my full screen. So that it will be pretty easy for us to go through this, and then everyone will follow along. All right, let me share my full PC. So entire screen, I think that's the post. Okay. All right. Can you see this? Can you see this? The television that is on. The television that is on. So that was what I was talking about. We have already connected this, so we don't have need for it. So let's go back to our packet tracer. I said the instruction said we should click on the Office PC. So we'll click on the Office PC. This dialog box have appeared. And he said we should click on the desktop. We should click on the desktop. I'll click on the desktop tab. I want to find this to the top. So I guess you all can see me now. So you can see this desktop. I clicked on it from the instruction. So he said this is where we'll do the IP configuration of the thing. Are you still with me all, please? Are you still with me? If that is so, please go ahead. All right.
Yes.
Okay, thank you. So let's continue with the instruction. He said we should click on the IP configuration. Look at the IP configuration. My mouse is on it. I'll click it. So he said click DSCP. So DSCP, though I've not taught it, DSCP is what enables a particular device to get IP address automatically without you configuring it manually. That means you entering those addresses by yourself. So it helps you, it just gives you to you automatically. So many of you are using DSP because your internet service provider gives it to you automatically. They give you IP address. You don't need to start entering your own IP address. They don't need to, you don't need to pass through the stress. So what makes it able for you to receive IP address whenever you are connected to the internet or whenever you on your mobile data is because of DSCP. So when they say we should click on DSCP, they want us to automatically what? Receive IP address from our what? Home router. So when I click on it, it starts requesting IP address. And as you can see, it has given it IP address 192.168.0.2, subnet mask 255. Okay, this is, I've assigned it.
Please, I'm not seeing your screen, no.
You are not seeing my screen.
It was showing before, but it's not
Are you
showing
guys?
again.
You said?
Yes, it was showing before. It was showing before,
It
but it's
was
not
showing
showing
this.
again. Yes.
I can
Okay, it's
see your,
showing now.
I can see your screen.
I can see it
I
now.
can see it. So
If that, you know that is your network, oh, because I know that even seeing the screen while I'm sharing it with you all. So,
and the thing is, if they cannot see it in their network.
so then he said we should click on the DSCP. We have done that. We can see that our computer, the Office PC, have automatically received IP configuration. Also, what did they say we should do next? Oh, it was trying to explain to us what default gateway is, what subnet mask is. So we have already gotten. So he said we should then close the IP configuration. If you are seeing the instruction is by the other side, as I'm reading it, I'm doing what the instruction is saying. Sorry, I'm doing what the instruction is saying. So what did he say? He said we should do what? He said we should click on the web browser. This is the web browser. I've clicked on it. So let's see. This is the normal web browser you used to have when you enter your system. This is the same one that is here. So we have clicked on the web browser. This is how where you type in your
I
URL
cannot see
when
the
you are
screen.
also. You cannot see my screen. You cannot see my screen.
I can see your screen. I think it's their network.
All right. So from there, the instruction says we should do what? He said we should enter the IP address of the home wireless router. That's the default gateway into the URL. But let me go and find back that default gateway, please. The default gateway is 192.168.0.1. So that's the router 192.168.0.1. So this is me connecting to the router. I want to configure it. It will ask me a username and password. As I already told you guys, these routers have default password, username and password oftentimes. So you have to change it. You don't have to use the one that it came with. As you know, what I'm doing is simulation. These devices come as physical devices. That's to say, the way I plugged in simulated cables, the same way you plug in physically the cables and then start doing this thing I'm doing. Once you turn on your PC, then it will bring up something like this way I've brought up, or this dialog box I've brought up, and then you can now be able to enter into your web browser. Sorry, you enter into your web browser, the default IP address of the router. It is always written on the router's body. So the only thing you need to do on the router, connect to it via the network, then enter the default IP address. Something like this will pump you for the username and password. So the username is, as they told us here, is admin, and the password is admin. So this is the default password. So it will open up the router interface. As you can see, this is that thing I was showing you in the last class, that diagram that you saw. So we need to configure this router. So what is it saying? Okay, locate the network setup area. This is where you can configure the router DHCP server. Locate the minimum number of users field, enter 10. So we want the number of devices that can connect to this router to be only 10. So as you can, what's the problem? What's the problem? Who is on our mic? Please, are you guys hearing me? Are you guys with me? Okay, thank you. So what we simply need to do is this. He said we should change the number of persons that can connect to our network to 10. So we only have a maximum of 10 users. The same way you can also set the maximum number of persons you want to connect to your hotspot while you on it in your phone. So from the diagram, we can see the maximum number of users by default is 50. But he said we should give it what? 10. So we'll click what? 10. We have changed it to 10. Remember, all these tabs here are all used in configuration. So currently we are just in the basic setup configuration. So when we log in, this is the basic. So we can use any of them depending on what we want to do. So, but when we logged in, they said we should change our default maximum number of users that can connect to our network to 10. And we have done that. What else did he say we should do? Scroll down to the bottom and click and save the settings. So when you do anything in the router, when you configure anything, please save the settings. So as we have changed it to 10, at least any user that is more than, once it's up to 10, the network cannot be connected to again. That's what it implies. So it said request what? Timeout. So what we just need to is to go back and enter our router this again, our router IP address, and log in back again. So just be with me. So let's click on the web browser. So these settings that I changed altered something. So it has to log me out. So I have to log in back again to continue the setup, to continue the whole setup that we are trying to do. So still be with me. So we're almost done with this exercise. I will still also be sending this packet tracer for people who have packet tracers in their system to still try out some things. I think this should be the 192.168.0.1. So all right, so admin still remains. We are still using the default password. We'll have to also change it, but let's do with some other settings as they told us. They said we should click on administration. Look at administration. You want to change the default password, which is a good idea. So we want to change it. What's the router password they said we should use? They said we should use my password one word, exclamation mark, I. So we'll do the same. We'll re-enter that, my password one, I. So once we are done, We will now do what? We will now save. We will now what? Save this setting. So once we do it, will log us out. It will log us out. It will require us to enter this password again. My username is what? Admin. We didn't change the username. Admin. But it's good to change the username as well. Password is my password 1 I. So your settings are saved successfully. So we'll continue. So our password has been changed. What did he say we should do? He said we should configure the wireless LAN. That thing I was telling you guys, if you follow that slide I shared, the topic that we are treating, everything that was said in that slide is what I'm trying to do. First of all, they will tell you to do what? They will tell you to dictate the number of persons that you want to connect to your network. Then secondly, they will tell you to change your default password or username setting. Then thirdly, they will tell you to choose the wireless channel or connectivity, which is what we are doing, 2.4. You know, wireless networks are between 2.4 and 5 gigahertz. So we'll choose the one that will be favorable to the devices that will be connecting to our system. So from the instruction, what is he saying? He said we should, and then click on wireless tab. We should click on this wireless tab and then scroll to the top of the window. Okay, click on, and for the click enable. Let's enable the 2.0. So we want every devices that use the 2.4 gigahertz wireless devices that use the 2.0 to be able to connect. So we'll enable it. When we enable it, we will change the network name SIZ. As I told you, always change the network name. So we'll change the network name to my home. So once we have done that, so we can choose to either broadcast or not. So when we enable, that means anybody, once our network is on, anybody can see. When we disable, that means nobody can see. They have to enter the name and the password. But when we broadcast, they can be able to see the name and then enter the required password. So they said after we are done changing that, we should go to settings and save settings. We should go down and save the settings that we have done. Is there any other thing that they say we should do? All right. This will help authorize. Now you will configure my home network. This will provide click on the wireless security. So wireless security. So we want to put our wireless security in place with regards to the 2.4 gigahertz frequency. Then it said we should do what? Click on the drop-down menu for 2.0 network and select WPA2 personal. This is a security form of our network. So people that are logging in will use a password to log in. That is what we are doing. We are configuring our network to have a password so that people that will be logging in will be using it. And he said we should use what? My passphrase 1 as a passphrase. Know the capitalization is important. So this is what they will be using to log in. So anybody that will connect to our network will see our network name as my home, and then they will require this password to be able to log in. Then when we are done, we will go back and click anything that we'll do in our router. We save the settings. That's the thing. So once we have saved the settings, what does this say? You said we should configure IP address and test. We should configure IP address and test connectivity. So we are done with configuring our router. As I said, those things I said in the slide is what I simply did. I told you guys, put in a password, rename your default network name. Then what else did I say? Change the frequency band. So you can choose between 2.4 and 5 gigahertz. So if your devices are using 5 gigahertz frequency, Of course, you will select the 5 gigahertz. We will enable it. Where is that thing? Look at it. We will enable it. But we just enabled for 2.4 because all the devices that will be connecting to our network will be using 2.4 frequency. So other ones we didn't enable it, that they are disabled. That's to say this network is only serving for 2.4 gigahertz of the. So if any device is using 5 gigahertz, it can connect to this our what network. So these are the things that we are in the slide I was trying for us to what see. So once we are done, we can close this and we are done with our wireless router setting. So this other one here, this other things is to configure IP addressing and test connectivity, but they are not really that. I've not taught them, but I was just trying to show you what it means like to configure your home router. So these other ones can also be done following the instruction. Click on the laptop in the living room, click on the desktop, PC, wireless. So you can just easily follow this one. But the major thing I wanted us to understand is the ability to configure this home wireless router. You can see our completion rate is 78%. If I do these remaining things, it will be at 100%. But that is the simplest way to configure. There are more things you can configure, but those are the basics, at least for the start, since you are not really going to be doing networking as an engineer, but at least let you have the basic foundation of what it is to try. So that's all I wanted to show you all before we continue on our classes today. Are you all with me? If that's so, can you get a thumbs up? If not, can somebody raise up their hands to address any concern? All right. Okay, Stella. Stella, I can see your hand. Okay.
I wanted to ask the IP address.
Yeah.
Are you pressing it on a web browser or I
Yeah,
don't
yeah,
really get.
yeah. Okay, look at how it works. When you buy a router, when your service provider gives you a router, at the back of the router has manuals or instructions or comes with instructions. It will contain the router's IP address. That's to access the router interface as I did. So the only thing you need to do is plug in or on your router. Either you connect wirelessly to it or you use wired. So there is provision for wired configuration and there is provision for wireless. So when you connect it to a wireless thing in your system, then you open your browser and then type in the router's IP address. When you type it out, that kind of interface that you saw that opened up to me will open up to you. Then you now start configuring anything you want to configure for your router. You can change the name, you can change every other thing. You can be able to do so many things depending on what you want to do. You can change the number of users that can connect to it. I don't know whether that answers your question, Stella.
Yes, it does. Thank you.
All right, Elizabeth.
Okay, so I wanted to ask, does this also apply to MiFi?
Yes, yes. MiFi, yes, it applies to MiFi. MiFi will have an instruction you can change from. Look at the MiFi back. Most of you that have MiFi, you will see the MiFi what is it called? IP address. So you can connect to it once you on the MiFi. You are connected to it on the network. You can then enter the IP address of the MiFi and then the password that was written down there and then configure it the same way that you saw me do this thing. Enter the what is it called, the IP address of the router. You enter the IP address of the MiFi, but make sure you are connected to it first to say. You must be connected to it before you can change any settings pertaining to it. So when you enter it, it will ask you for the username and password, and the username and password is written on that MiFi. Then when you enter into the interface, you can now start changing things. You can now start changing number of users that can connect to your MiFi. You can now start changing the password. You can change the MiFi name. So that's it. Did I answer your question?
Yes, sir. Thank you.
All right. Uh, Assuming we have more time for this thing, we'll do the ground up, like we'll do networking, everything on networking. Just that as a cybersecurity personnel, you need those strong foundation, but basic foundations as well. Why I mean strong foundation is that we will still guide those that want to have more idea of the intricacy, that's the nitty-gritty details. we can still share resources and share courses for you to do that. As I said, I have an opportunity as a Cisco instructor to give you those resources if you need it. So, but for now, these are just to help us to guide our efforts to keep on and lay the proper foundation through which everyone is going to thrive. Beyond here lies more learning to do, but this one can get you to a place whereby you can have an internship or you can start making impactful changes in the organization you are working for or you hope to work for. So is there any person that has concern? Are we good to go? So that we round up on the last thing that we are doing, which is also related to what we are doing now.
Please, Mr. Michael, please, can I say
Yeah,
something? Please,
yeah.
I'm interested in the packet trace.
You said what?
I said I'm interested in the packet tracer. I don't know if you are going to drop it in the group.
Yeah, I will drop it. I'll drop it for those of you that have packet tracer this thing. And moreover, I will still drop I will start dropping those courses as I said, especially for those that want to explore beyond what we are doing. Like you want to explore, you want to you want to get more things. So I will still be dropping courses. Sorry, I lost you guys for a moment. So did I answer your question, Rafiat? I will share the packet tracer.
Yes, okay. Thank you very much. Yes.
All right. So can we continue what we are doing the last time, or is there anybody that still wants to say something? All right. If you can continue, can I get a thumbs up? All right. Thank you. Thank you. Thank you. So I hope you can see my screen. So, Bola, are you on the call? Are you on your system? Just
Yes,
in case
sir.
you are on your system.
Yes, sir.
And just in case, maybe I'll use it as an alternative just in case. All right, so let's proceed further. We have already started something on network communication. So I was saying something with regards to network communication is essential, trying to know how these devices that make up the network communicate, how they are able to transfer message from one point to another, what is the nitty-gritty details of one system sending message to the other without being physically connected to them or per se being also physically connected, whether wired or wireless. What makes the thing able? Why will a system manufactured in France that's supposed to be speaking another language will communicate with a system manufactured in Nigeria that's supposed to be speaking pidgin? So how do these things come to be? What makes it possible? So without that knowing those things, we can probably be able to protect those systems in case if an intruder wants to have access to that. So we talked about protocols is what makes those communication able to happen. We talk about using the human kind of conversation systems. We were able to express how these communications work, the method, the language used in our normal communication way we do it. So this is also the same way, probably is applicable to the world system. They have protocols in place, they have rules that guide them. We now started talking about the characteristics of these protocols and why we need them. That is in this protocol that specifies the way a message can be formatted. It is this protocol that actually acknowledges when one message is received. And then it tells us about encoding encapsulation, how this message can be transform to another thing so as to enable it to pass through the wires and get to the device as it meant to get those messages. or how this message can be folded up into something, and so that it can be able to be sent across one device, because that device will better understand it in that way or in that format. So when that device gets it, you have to strip it, and we use the scenario of the letter and envelope, letter and envelope of a scenario to actually depict what an actual network looks like, how we can name the sender of the message and the receiver of the message so that it will properly get to them. In the letter format, we talk about the person's name and address, while in the actual network, we talk about the person's IP address or the person's MAC address. So we are trying to get to used to how to use the normal analogy to also express what we are talking about. Am I fast? I'm trying to review what we did the last time. I hope you guys are not confused on the way I'm talking. Please, I don't talk this way when I'm teaching. So I was trying to do a quick review. Okay, so thank you. So I was just trying to do a quick review. So we also get to the communication standards, whereby these things are mandatory for it to be done this way, so as these devices to be communicating effectively. So if I'm speaking French and English and you only speak English, so there can be a communication standard that say every communication, since most of these devices understand English, every communication should be in what? English. So every manufacturer of these devices or technology would have to manufacture a device that speaks what? English. Remember, what I'm giving is just something that is relatable. So don't think I'm just saying something that probably is technical. This is something that is relatable. So when I say a device is speaking English, of course, we know that they don't speak English, but it's just for us to understand it the way we have to get it started. So when we do a must-do rules, we call them standards, because everybody have to what? Abide by it. Everybody have to do something to be able to fit into the standard that have already been what? Set. As many of us still have organizational standards, devices that communicate on the network have their own word standards. That is what I was trying to explain in the last thing. I will say that without these organizations that manage these standards, it can't be possible to keep up with them in due course. So there is nobody that is going to be monitoring them. Nobody will be checking in if various people are keeping to these standards. So when there are organizations that look out for these things, when the organization that checkmate the devices that come online or come on board in the internet space, or the technologies that are being manufactured, where are people that are looking so intently that these devices are meeting this standard, we term them as network standards organization. And we mentioned a few number of them. We have the IEEE, INA, IETF, ICANN, ITU, and TIA. So these are just few of them that are able to help us to manage the processes that goes with communication between what devices that are connected to the what network. So we now thought about where these documentaries are kept, because if these documents are not well nurtured, are not well updated, over the period of time is going to phase out. Everybody will go back to the norm. So there is a place where these documents are kept, and this is what we call the ROFCs, request for comments, where all the developed standards are kept. So if we say something is to be done in a particular way, if we say that something is to be done in a particular way, it has to be documented. If not, nobody is probably going to reference it. So that's why we brought about the request for comments, is what makes it possible or what makes it feasible for most of these standards that help in communication to be able to what? To be stored, saved, and can be what? Referenced. And that is what we are saying when we talk about network was organization, before we are meant to talk about the network communication standards. Are we on the same page? Was that a quick review? Did I actually express what we were trying to say the last time? Are we on the same page? Did I rush it? I think. But that's what we have done, is just to have a quick overview. So today we want to talk about network communication models. Network communication models. All right. So network communication models. Then we want to be able to see how these communications happen. We want to see, we have to want to get a live experience of how these communications that happen in a network happen. That is why there is network communication models. If you can't be able to visualize, bring it home to ourselves when we talk about devices communicating, then invariably we can be lost out when we try to what protect these devices. But what communication models are, just the same way a tailor wants to make a cloth, a tailor doesn't just make out a cloth from the blue. The tailor will tell you, oh, Stella, come, let me what measure you. If it doesn't measure what Stella, what else should we do? Will she do? She will get what we call an idol. That idol is more like a perfect representation of what Stella could look like. Then she will now use that idol to what? To measure it out and then sew a cloth that will perfectly what? Fit Stella. So this the same way is what we call models. Models is a depiction of something that we ought to what we want to what create, or something that is already what existing. That's a kind of representation, a kind of thing that gives us a real life scenario of what something is trying to what express or explain about. So when we talk about communication models, we are talking about a view, an overview, a thing that helps us to depict what an actual communication looks like in a network. And there are two of these kind of models. We have the protocol model and we have the what reference model. In the protocol model simply only tells us how protocols, as we have already said, we told you that protocols are rules that guides what? That guides how devices on a network what communicate. So when we talk about protocol model, it just simply tells us how these protocols work. So every protocol that was manufactured for the communication to happen on a network, all these protocols, the protocol model helps us to what? Helps us to know how each of them work together. So from the standpoint of the least protocol to the standpoint of the greatest protocol, from the standpoint of other protocols, how they come together in order to make network what communication what happen. An example of this model is the TCP IP what model. So the TCP IP model is an example of the what protocol what model that helps to tell us how various protocols work together in order to make what network communication what happen. So as I said, protocols are rules that guides what communication. So when you bring in a model that actually depicts how these protocols work together, you are actually creating an image to a person who is willing to understand and then work with how a device uses these protocols to communicate and can be able to defend against any form of threat that comes up when these protocols are not acting the way they are supposed to what act. When we have rules, when that rules is broken, we will often what know. Example, when we said nobody should make noise. So if there is a sound, we have already known that a rule has been broken and we can do something about it. So that's the same thing when we talk about protocol. So those rules, these guidelines work together to make communication happen. So when these rules are broken, we know that something has already what gotten wrong. So that's what these protocols help us to what do. They actually depict for us how rules work together in order to what? In order to make communication what happen. So the another one is the reference model. The reference model takes another form altogether. Instead of it to tell us how protocols work together, like how the protocol model does, it tells us how networks are classified under layers, like from the least layers, how network messages go from one place to the another, the step they take, each step. Just imagine you trying to say, I have 7 steps to climb to be able to get to a particular office. The step one that you take, sorry, you have 5-story building. You need to get to the first story, get to the second story, sorry, get to the second story, get to the third one before you get to the last one. So when you get to the first one, it helps us to define what you can be able to happen when you get to the first building. When you get to the second building, it tells us what will happen when you go to the second building. When you get to the third building, it tells us what will happen when you get to the third building. So the reference model is specific on how or the paths each information takes to get to the actual destination. So it classifies or tells us what happens at each stage of information transfer or each stage of what communication. But the protocol model is different in the sense that it tells us how rules work together in order to make communication happen. Why the reference model is not interested in the protocols, even though each of these protocols work in the layers to make communication happen, but it tells us what happens at each layer. So if all the protocols in one layer come together to make something happen, the reference model will just tell us what happens in that layer, but the protocols tells us what each protocol does. So that is to say the protocol model is focused on the rules, the guidelines, the things that happen to make network communication happen, while the reference model focuses on the stage by stage or process by process stages of communication have to go through in order to reach the intended person. And the example of that model is the OSI model. It was developed. So the TCP IP model was developed for the protocol model, and the OSI model, the full meaning is open system interconnection. But whenever I drop any form of short acronyms, please do well to get the meaning. I don't know if you all are with me on this communication model. I was just trying to explain everything I can be able to know. So if you got me, just get a thumbs up. If not, bring up your concern. I will still address them. Rofia, do you want to say something? All right.
Yes, I don't really get the difference between the two, please. I don't know if you can just try to explain it again.
All right. So what I was trying to explain, Rafiat, is that see types of models. Protocol model focuses on protocols, and I've already defined what protocols are. They are rules. So all the rules that make communication happen. That is what the protocol model will try to explain to us. So if there are 25 protocol rules, it will tell us what each one does for us in communication. Did you get that one? While the
Yes.
reference model doesn't have anything to do with what protocol, it just kind of classifies the way information is transferred from one place to another. It classifies it into stages. So if assuming you want to get to a 5-story building, it will tell you what you can see in a first-story building. When you climb a first-story building, what can happen in that first-story building? If you go to the second-story building, it will tell you what will happen in the second-story building. If you get to the third, it will tell you till you get to the fifth one. So the reference model is specific on the stages communication have to pass through. It's not focused on the rules, it's focused on the stages. So that is to say that there can be more than one protocol acting on a particular stage, but the reference model will just tell us what happens after all those protocols, or what happens when those protocols do something, to tell us what will be the actual effect on that stage. Are you with me? So that is that protocol model is focused on routes, while reference model is focused on stages of what communication, which are called what layers. Is that now well understood?
Yes, thank you very much.
All right. So is there any other person? Are we still on the same page? Are we running too fast? Can we move forward? If that's so, can I get a thumbs up? If not, can I see somebody raise up their hands to talk about something? All right, thank you very much for that. Okay, so Rafiat, you can mute your mic if you are done with what you want to ask. All right, so let's move forward. So you want to talk about the layer, that's the word protocol layer. The protocol layer, I said the example of it, or the special thing is the TCP and IP model, is a representation of the protocol layer. And it is what? It uses 4 layers. Don't confuse when I say layers with the what is it called? With the reference model. Reference model are specific on layers. But when we come to layers of the TCP IP model, that is to tell you there are protocols that function within each layer. While the reference model gives us the stages which are called layers, the TCP IP model will also use these layers to tell you what happens, protocols that happen at each layer. So that is not to be confusing you, that there are many rules that work in layers. So the thing TCP IP model is focused on is to tell you those protocols that work in those layers. Are you invariably doing it? That is, say the TCP IP model, even though it is telling us something on network access layer, internet layer, TCP layer, and application, these are the 4 that it highlights, and these are the protocols that work hand in hand in order to make communication happen in those layers. So what are those things? When we come to the network access layer, we talk about the hardware devices. We talk about your switches, we talk about your routers, we talk about your computer, we talk about those. So we now say which layer, which protocols work within this layer when we talk about the TCP IP model, since it has 4 layers that it wants to talk about based on the protocols that work within them. So which protocols functions to enable our devices, those cables that we plug in, to enable them so that even when we plug in cables, those cables can be able to conduct or pass our information through. That's within the network access layer. What are the protocols? And that is why I said Ethernet and address resolution protocol works at this layer. The Ethernet protocol and the address resolution protocol works at this layer. So these protocols work to ensure that all the hardware connections are enabled and are working in perfect condition. What makes it possible for you to plug into a wire and that wire says and start blinking a green light to show that there is data transferred is because the internet and the Ethernet protocol is working. So what makes it possible for your data to pass through those wires is because the Ethernet protocol is working. Then after the network access layer, we have the internet layer. And this internet layer is what helps to transfer information from one point to the other. So sorry, transfer information from one point to the so this is the one that grants us ability to be able to access the internet, for us to be able to get a IP address, get a special recognition that we have connected to the internet, and our device is able to communicate on the internet. It is the internet layer. So within the internet layer, we talk about devices communicating with each other, devices being able to locate each other, devices being able to see each other. So anything that has to do with coming up on board on the internet and then be able to communicate with various other devices has to do with the internet layer. And one of 2 protocols that are essential, I'm just giving examples of the protocols that work there, is the IP protocol, and the ICMP protocol. Please find out the full meanings of this thing, ICMP protocol. So find out the full meaning of these things, as I already said. Then the other protocol is the transport layer. In the transport layer, the protocols that work in the transport layer is the transmission control protocol and the user datagram protocol. Anywhere you see me use short forms, please use find the full meaning. I wanted you to research and get it, because when you research, you will help you to read more of what these protocols are, even though I'm going to still treat each of them, what those protocols are and what they do. So the TCP UDP are the protocols that function in the transport layer. So what does the transport layer do? What does this protocol help us to do in the transport layer? So as I said, in the TCP IP protocol model, we have 4 buildings to climb. So when we get to the network access layer, we have We have 2 protocols that help to manage our hardware connections. When we get to the internet layer, we have more than 2 protocols, but I'm just highlighting this one, IP and ISP, to ensure that our devices are recognized on the internet. Our devices can be able to see other devices and can be able to send messages to other devices. When we get to the transport layer, there are also protocols that helps us to ensure, like when you see in the transport layer, I said communication between devices. Let me explain better what that thing means. That your message that you sent left that place and got to the actual person is because there is a transport mechanism. The same way that you want to go to a 2nd-story building, you require an elevator. What makes that message to get to the particular person is because of the transport layer. If that message didn't get to that person, the transport layer will report back to you that this message was not received by this person. So that is what the transport layer does. Why the internet layer helps in identification and connectivity of devices on the internet, for them to see each other, for them to know that this one is located here and here. The transport layer is the one that ensures that messages get to the persons that are meant to receive those messages. So there are protocols that help to make that happen. When I talk about protocols, remember it is rules that make something happen within the transport layer. So those are the TCP, transmission control protocol, and the UDP. There is a difference between them, as I said, it's not up to us for us to start dissecting what these protocols do. There are topics that will treat what each protocol do for us. So then we have the application layer. The application layer provides services to the user. So the application layer is the one that serves us. When we go to systems, we use various applications. It's because the application layer is there. So we browse and see the web pages is because there is application word layer. We might not have a good background of knowing what the transport layer is doing for us. We might not have a good background of knowing what the internet layer is doing. We might not have a good background to know what the network access layer is doing if you don't even have where a physical device is connected. But we often mostly interface with the application layer because this is where we use to request and gain what? Information. So this is what the TCP IP model tries to give us. It tries to give us that there are 4 layers I am considering. And in these 4 layers, there are various protocols that work hand in hand to ensure one thing is what's happening or the other to achieve network what? Communication. Are we on the same page on this, or do we have concerns? You can raise up your hands, please. If you're on the same page, you can give thumbs up and we'll continue. All right, thank you very much. Praise.
Okay, I wanted to ask for the network access layer. I don't know, I cannot see the screen. After the internet, what's next? The screen is not showing that part.
ARP, Address
Okay,
Resolution Protocol.
okay,
ARP. There are
thank you.
more protocols. I'm just listing the ones that are most commonly used. So, is there any other person? So the TCP IP model have how many layers? Just 4 layers. And their protocols are function in those layers to make these things available to us or to make some certain things obtainable for our networks to be able to communicate. So let's go to the other type of model. Okay. Okay. So this is a depiction of what I wanted to show. All right. You can see the TCP IP model. We have 4 layers, and then there are protocols that are essential. But the emphasis of TCP IP model is to showcase us these protocols that work. That is the emphasis, right? So the emphasis is the protocols when we talk about the TCP IP model, even though it will mention the layers that it has 4 layers, but it's a protocol. So we can see the internet and wireless LAN. As I said, it's not just the internet, the wireless LAN also works in this network access layer. These are protocols. We have the IP, that's the internet protocol working in the internet layer. We have the other ones, ICMP is also here. We have the TCP UDP, that's also another one working on the transport layer. We have the HTTP, TLS, DNS, domain name system, transport layer security, hypertext transfer protocol. These are some of them. I'm just mentioning them, but just ensure you be able to know what those things mean. So we have the other type of layer being talked alongside, being compared alongside. As you can see, the OSI model has 7 layers. So it shows us an actual depiction. As you can see, OSI model, as I talked about, the emphasis is on layers. So it shows us the actual overall description. This one is more of shortening it because it's trying to explain to us the protocol. It's just giving us 4 layers and the protocols are working on. But this one gave us everything that is obtainable when we talk about network communication. The OSI model is broad because its emphasis is to tell us the layers that exist in network or makes network communication possible. So as you can see, the data link and the physical layer is condensed in the OSI model, is condensed as the network access layer. The network layer in the OSI model is the same thing as the internet layer in the TCP IP model. The transport layer is still remaining the same. The session, presentation, and application layer are all condensed under the application layer. That is trying to prove the point I was trying to make. TCP IP model emphasis is on protocols, while OSI model emphasis is on what? Layers. So when we want to talk about in a comprehensive way what happens in network communication, we use the OSI model to understand better. But when we want to talk about briefly or to give a snapshot of the protocols that make things happen in the communication, we talk about the TCP IP protocol models. So are we on the same page with this diagram? Or should we move forward to go and explain the OSI model at harmony? Bola. Bola, my battery is low. You have to share your screen. I will log in from my mobile device to conclude on the lecture. So Stephanie, you can ask your question, but my Bola, are you with me?
Yes, sir.
See, please, so you have the slide already. Just share with us so that I can be able to round up this topic. It's just small things I reminding that everybody. You already have the
Okay,
slide now, right?
presenting now. Yes, I have a slide.
You said?
I said, are you going to stop presenting now?
You said what?
I said, are you going to stop presenting?
Yes, I've stopped presenting. I want to log in from my mobile. My battery is low. My this thing is low. So
Okay, I
I will
can.
continue. Stephanie, I can see your hand is raised up. Once I log in from my mobile, I will answer your question.
Okay, sir.
All right, sir.
So I'm still with you guys. We are not going anywhere. We are on this together. So let me stop presenting. So Bola, take up. I'll make you the co-host just in case when you want to stop the recording. So I think I'll stop here and continue with my mobile. Thank you very much for being with me on this journey. All right. Stephanie, I'm logged in now. You can ask your question. Stephanie, you can ask your question.
Okay, good evening, sir.
Good evening.
Good evening. Yeah, please, I would like to know if you would explain how the OSI, like each specific layers in it
Yeah, yeah.
correspond to the other location. If you would
Yes,
explain it
yes.
in detail.
Yes, yes,
Okay.
is the next slide after that diagram. I just wanted to show you the diagram that compares between the OSI model and the TCP and the OSI model and the TCP IP. So the next slide is the explanation of the layers of the OSI, everything about each of them. So if you
No.
share the slide, you will see it. I will explain all of this.
Sorry. Thank you.
All right. So is there any other person that have any concern? Oh, thank you very much, Bola. Thank you for coming through for me. Um. So we'll move forward. So if you are done with your question, you can raise down your hand, Stephanie, while we continue. You can go down to where our slide is, where we are currently on. Okay. So we are done with the image. We are going to the OSI model. So I want to explain the OSI model. As you can see, the OSI model is quite different from the TCP/IP model, but they are related very much in the way they are working. So the OSI model has 7 layers because it's comprehensive. It tells us what happens at each stage of communication. So starting from the physical layer, this is where we started the cabling aspect of it, trying to cable your devices together, trying to fit in your various kind of devices together. This is where the cabling happens. This is where the physical devices come to play. This is where they are interconnected. This is where they are fixed by the network engineers. So this is when we talk about the physical medias, we talk about the cables, we talk about the switches, we talk about the router, we talk about your laptop, we talk about anything that can be done in a physical setting that can be interconnected for them to communicate. We talk about them in the physical layer. The second part of it is the data link. So beyond the physical layer, we go to the data link layer. So we don't see this type of ones. It happens like more like a software-based kind of happening. You don't see them. This is where we talk about frames, transmission. Uh, yeah, I will send the slide to the group. Abby Harmony, I will send the slide to the group. That's not a problem. I've always been sending all my slides. That's not an issue. So, but the thing is to more importantly be in the class. If you are not in the class, you cannot understand the slides. I'm just being uh, truthful on this. That's it, honest and everything. That's what it is. That's why we have been going about this class. So you sure you are in the class, at least you have gotten a portion of the class. You can flow with the slide. So I will always send my slides. So as I was saying, data link layer is more of where the things start happening, where the data transfer start happening within those devices that you have connected. This is where your information is now being transferred as what? As I said, information are transferred like what? Light, light, electric, and what again? Light, electric, and what again? Waves. That's infrared waves. I mean, infrared. That's radio waves. Yes, that's the microwaves. Those are the ways information can be transferred. So it's the data link layer that takes care of those things. This is where the transmission start happening. And as you can see, there is something that we call the MAC address. MAC address. These are specific addresses that we are giving to devices when they were manufactured. So every device that is manufactured have a MAC address. Those MAC address are a permanent kind of address that is given to a device. It kind of tells who the manufacturer is and then uniquely identifies that device is physically. It's a physical address given to every device manufactured. Your phone have a MAC address. Any device that is coming on the internet will have a MAC address. That is the same way I was trying to tell you that it is not just enough for you to have a name. You have a physical address. That physical address is your MAC address. For anybody to locate you, despite you have a name, they will first of all write your address. When they write your address, they will get to you by your what? Name. So let's assume your name is your IP address and your physical address is your no. If I use this analogy, you will get it so wrong. Let me reverse it. Assume your name is your MAC address because it doesn't change. Your name will remain the same until the day you decide to change it. But your physical address will always change. So your IP address is more of your location. The one that is given to you to identify you on a network is your location. So it is your location. But your MAC address is more like something that is permanent, which is your name. It is what? Permanent. It was given to you the day you were born. So the day any device was brought into this place, there is what we call media access control address. That is MAC, media access control, that is given to you, that is unchangeable. It will not change. It is rare for that device to change its address that was given to it by a manufacturer. So meanwhile, there is also another kind of address we need, and that address is called IP what? Address. That address is called IP address. It is given to you to identify your location. That is your physical address, where you are located on in a network. So when we talk about data link thing, we now start talking about how devices are able to receive information in a local network using that using that name address that was given to them. That is the MAC address. So they can be able to send because they are connected by wire. So one message can be transferred, or they are connected by a wireless network. One message, because they are on a closed base, one message can be transferred from one device to another. That is what happens in the data link layer. These devices are connected in a closed form, either by wire or wireless, and they can be able to send frames, which are called message, as you see. Frame transmission. Frame transmission is a name that is called when a message is at the data link layer. That is called a frame. But just know that it is data that is being transferred between those devices. Then we move above the data link layer. We now start talking about the network. This is where somebody have gotten on board on the internet. This is where somebody have gotten on. So he wants to communicate beyond their physical devices. And most at times they are giving what we call IP address, because without an IP address, you cannot communicate when you get to the network layer. So you can be able to have a physical and data link layer, but when you want to go beyond the communication that happen based on string and string, you want to go beyond communicate, because of course that's what everybody desires, is to communicate from one system to the another that are located in various settings. So when we talk about the network layer, we talk about communication that span across from one device to another. They started communicating. So another form of address is given to you here, which is called the IP address. As I invariably try to differentiate between the two addresses, MAC address, take it as your name. It is a physical name that was given to you with the day you were born. The same thing that comes with a device. Then your address, your location on the internet is another type of address that is given to you on a network layer. It's kind of describe where you are located in a network. So somebody can be able to send you a what? Message. So it's not just enough for somebody to send you a message based on your physical location. That is using your IP address. They will also have to know your MAC address, which is your name. So they will address you both by your physical location and by your what name. So they will call you by your what name. So that is why both the data link and the network as layer is very, very important in our regards. Stephanie, you have your hands raised up. You can talk.
Yes, sir. Please, I want to quickly ask.
Yeah.
Let's assume, yeah, I'm in a place where there is no network, or my service provider does not have network in that particular place. So I decide to connect to someone's hotspot. Now, when I connect, whose IP address am I using? Which IP address is going to be on my own device? Is this going to be my own or the person's own? Since I'm now connected to the person's network.
All right. I will answer that. Look, there is a reason why we will not answer this question plainly, because why? There is what we call IPv4 and IPv6, which will also be treated. So in the IPv4 kind of network, right? Many devices can have in time that is what we call private IP addressing and public IP addressing. So the public IP address is the one facing the internet. The private one is the one that is internal. It doesn't go outside the internet. So for you to be able to communicate on the internet, you have to use a public IP address. So most of the devices we all are using, most of the things that we are just using one public IP addresses. Most of inter because IPv4 address have been exhausted, as I said. Okay, I've not said it here. It has been exhausted, so that's why we transition to IPv6. So invariably, when you're connected to someone hotspot, you are using an IP addressing. Two of you can even be using one public IP addressing, right? So you two can be using one IPv4 address. So public IP. But how it's supposed to be that people are not meant to share IP addresses, but it was due to the deprecation, something to deprecate is what brought about people that can share one IP address. All right. So what happens now to differentiate between who has who and what has who is what we call port numbers. Port numbers identify the kind of applications that are being opened in your own system against the application that is being opened in somebody else's system. So port numbers are from 1 to over 65,000. So each port number is used to identify you. So in the sense that we can be using one public IP addresses, but due to we are making reference to different port numbers, so that communication will be traced back to us based on those port numbers. That is to invariably say that I would just tell you that normally you're supposed to have one IP address, your public IP address, but at times you might see yourself using the same IP address as the person that you are connected to with on the same network. That means I'm talking about the public IP address now, but the private IP address will differ. The private IP address will differ, but the public IP address, that's the one searching the internet, will be the same. Is that what I explained to you, Stephanie? Okay.
Yes, sir.
Thank you very much. So beyond the network layer, as we are saying, we have the transport. We have already said something on the transport. It's still the same transport that is applicable in the TCP IP model. So it helps us to ensure that communications are going on are reliable. It reaches the person that we are trying to send it to. So the same way that elevator helps us to get to where we are getting to. That is what transport does. The same way we enter a car to our location, that is what transport does. So it helps to ensure that we get to our exact location. So another one that we never talked about, somebody raised up their hand. You can go on, Faithful. Yes, sir. Yes, ma'am. Sorry. Is that?
I said, Stephen asked a question, so I was just like thinking about something. So that was the very ask.
I didn't get you.
So, can you hear me?
Yeah, I can hear you now.
Okay, I said, Stephen asked a question. I said, based on the question that Stephen asked, so you
Yeah,
explained it. But your explanation, I was thinking about something. If using two hotspots, we are going to share the same IP address, but I don't know the same IP address, but you talk
public,
about, okay,
public. I
the
said.
same, okay, the same public address.
Yeah.
Okay, and you talk about is it sport, that is between 1 to 65,000. That through that
Yes.
1 to 65,000, they can differentiate it that we are using hotspot. Is it that if those people tracking someone, assuming somebody is tracking my phone and I'm using hotspot with somebody and we have the same public address, is it so that spot they'll be able to get me or what?
All right. Okay. So look at what let me explain this thing. It's called what the protocol that makes this thing function is called NAT, Network Address Translation. Look at what happens. Every person have specific private IP addressing. As I told you, IPv4 address, that's the case study I'm using. If you are using IPv6 address, all your addresses will differ. So IPv4 IPv4 address is 32 bit. Do 2 times 2 raised to the power of 32. You will see it's over something million. And all of us on this internet, and many people are using 2 devices, is over that number. So it has been exhausted. So what NAT came to do, that's network address translation, is it makes it possible for many devices to be able to use one public IP address, but your private address still remains. But what is the difference between private address and public IP address? Public IP address is the one facing the internet, the one you use to get to the internet. Everybody can see, anybody can request information from you. But private IP address is the one that is hidden. Nobody can get to you because it's a private thing. You are the one just using it. So when you want to send that information to something on the internet or receive something from the internet, you have to translate that private IP address into a public IP address. That private IP address will generate what we call port numbers. Port numbers is more like a number that is telling us about the services that you are trying to request from. So if you are using WhatsApp, it might have something like, if your private IP address is 192.168.1.0, then it will display something like a colon, then put the port number as 2096. So 2096 is representing the particular service, which is WhatsApp. So when it is translating it, it will translate the 192, which is your public IP address, to a which is the private IP address, to a public IP address. Let's assume the public IP address that you, Stephanie, and you, Faithful, and Stephanie is sharing is 209.10.10.1. So it will translate it to that public IP addressing. So what everybody will be seeing on the internet is that public IP addressing. But that public IP addressing already have knowledge about the different port number that was generated based on the services that we are requesting for. So if Stephanie wants to request for something, it will generate a port number. Their device will generate a point number. So when that public translation is done, the translation that was done from private to public, it will keep memory of that, so that when it is returning any message that is coming from the internet, it will translate it back to the IP address and use the port number that was used to know which part of the device that was what requesting for that what exact what thing, and send it to that device. Are you getting what I'm saying? Was that what you are trying to ask on, or did I miss something on that?
Yes, that is related to what I was trying to ask. But
Okay.
another question I also have there is that if we are
Okay.
being tracked, is it the first number that we are being tracked? Because if more than we are using public, like what you said our public IP address, like it is like it's just facing the internet, while the private is made for only us. Now, if the public is facing the internet, how is it be that we are still able, as in, okay, let me use the word. How is it that they can still track us?
They
Like
can
we are
still
still being
track you.
tracked. Yes, something like that. Yes, they can still track me. Whereby I'm using normal public that everybody is using. Like you talk about me setting using the same public IP address. Now, the private IP address is meant for only me one. That is just like it's
Okay.
only me. Like, okay, why is it that they can still track me and still be able to track?
All right, let me explain this. Every protocol that was established were still established by humans. There is nothing that was established by woman that doesn't have its knowledge or tricks or tactics around it. No matter everything that you have produced in this world and tell me it's 100%, it can be 100%. It just needs somebody that has that the same knowledge to understand how those systems work and be able to intercept it. In the sense that there is network address translation protocol. So there are people who still understand how network address translation protocol works. So they are probably going to have their way in if they are so intentional about it. That is why amidst the network address translation protocol, we still have to put other things in place like the firewalls so that somebody cannot be able to meander through something and be able to get to us, because somebody can still send a malicious thing and the network address translation protocol will still forward it to you because you requested for it. Somebody just added a little bit of information. So when we talk about protocol, we are just saying they are rules. So their rules doesn't mean they have any security enabled on them. No, they don't have any security. It was later consideration that security started coming in view. So there are security that helps with regards to uh, guiding us. And most of them are the ones that I also have mentioned within. They are also protocols. So those protocols are also security protocols. We have security protocols that guides against those kind of things that will enable a threat actor to use the knowledge of how the NAT, well, that's the network address translation, to get back to us. Does that explain the thing that happened? Faithful, are you all right? So I think that's clear for her to give me a handshake. So we have the session. Session enables us so that we cannot be disconnected from a network. Session layer enables us so that we cannot be disconnected in a network. So when two devices are connected, a session is recorded. So your ability to stay here and your data is being recorded, or we are still on the same call, you are not disconnected, is because the session layer have established a form of connection saying these two devices are what connected. So that's what the session layer does for us, so that it will enable us to keep track that these devices have come in contact and then said to themselves we are bound to what connect to what together. So that's what the session layer does for us. Then the last part of the presentation layer is the one that actually presents information to us. It models the way this information should be received. It, like for instance, if you are browsing a site, those colors, those graphics that happen, it is the ability of the presentation layer to put it up in a way that synchronizes with our device. So we start seeing those effects. So the presentation layer is more of the thing that helps shapes the way informations appear when they reach to the person that is being sent those information. So that's what the presentation layer does. Application layer is always, you always know it is the same thing with the TCP/IP. Is more of the one that helps us to request for service and obtain the request that we have received. So it is the one we mostly interact with. So other ones below it is the one that we often are talking about now, so as to get accustomed to that. Are we all on the same page? If yes, can I get a thumbs up? If no, can I see your hands raised up to express your concern? All right, so can we move forward, Bola? Can we move forward? In access layer. So let's talk about the first layer. Let's talk about the first layer, the access layer. That's the network access layer. Let me just call it for the network access layer under the TCP/IP model. We might not be talking about the physical layer. We might not be talking about because the physical layer in the OS side, you saw that image I showed you. The physical layer plus the data link layer makes up the access layer in the TCP/IP. So that's why I'm talking about the access layer, because our intentions is to learn protocols, not majorly the layers. We want to learn protocol because those are the things we'll be working with when we are trying to either protect against intrusions, threats from cyber criminals. So what's the access layer? As I already said, this is where the real nitty-gritty connections happen. The physical kind of connection happens. The switches come together, the routers come together, devices start communicating by the means of wireless or wired form of connection, but in a local settings. This is what the network access layer grants us the ability to do. For this device to be connected physically, then you see that protocols that work majorly there is the Ethernet protocol, which helps in order to coordinate the rules or bring in the rules that make the devices able to work connect. So when we talk about access layer, have an overview of trying to connect various things together to for them to start communicating. So when you try to bring your speaker and bring your computer together using Bluetooth, we have already started talking about the access what layer. So that is the first stage, trying to connect, trying to bring together. So when we talk about connection, the first instance of initiating connection, just think about the network access layer. Can you bring down the slide? Is there any concerns on that? You can still raise up your hands. If there is not, you can give me a thumbs up. Any concern on the access layer? Okay, so let me show you what the access layer looks like, the diagram. All right, this is what the access layer looks like. We can see 4 PCs. We can see a switch. These are switch ports connected to those switch ports. As we are trying to do that in a router, you know that a router has a switch port. So we can connect those our PC to a router, or we can connect it to, but the router is normally functions in the internet layer though, but the switch functions in the access layer because it tells devices of various type to connect. So you can see how various devices are connecting, and you can see the thing I talked about, MAC address. MAC address, this is the physical, let's say the name that was given to those devices. uh, if I'm to express it properly, they are kind of come with it when those devices were produced. You can see them. So if PC1 wants to send something to PC3 at the access network access layer, it will call it by name 123486768ADE. Receive this information and it will receive it. So that is what happens. As you can see, the switch has a MAC address table. It keeps memory of all the devices that is connected to it, which port they are connected to, and then can be able to send them messages between them. So all these devices on the network access layer being coupled together can be able to transfer information to one another. So that is what a depiction of what the access layer looks like. Are you all with me on that? If yes, can I get a thumbs up? If no, can I see your hands raised up? All right, thank you. So can we move forward? So can we talk about the network media types? Because network media is part of the access layer because those are wires, those are cables. So as I already said, there are types of cables, and we have mentioned this before sometimes. We have the copper cables. When you are seeing us doing that practical, you saw when I was saying on copper straight through, copper coaxial cables. So those things is telling us that cables are essential to make these things work. So whenever we use the copper cables, we are trying to tell you that electrical signals is the means through which data is transferred from those systems, is a medium through which those systems transfer data. When we are using fiber optic cables, we are using light as a mechanism to transfer those information between those devices that are connected. When we are talking about the wireless transmission, we are talking about radio waves, microwaves as means of transmission between those connected devices. So your Bluetooth can come under the wireless transmission. They are using infrared rate. I don't know. I used to till today. I don't know how that word is called. Can somebody help us, please? Look, I am just what's people that what's that called?
Infrared.
They said is what? Let
Infrared.
me learn. So what is it called, please? So I will not be
Infrared.
disgracing myself again. Infra what? So
Infrared.
okay, I don't know whether I will be able to call that thing very well one day, but I know, but I will. So, but what I know, like, I know what it means, I know what it does, but I will learn how to pronounce it. I think one of them I've mentioned them is that reconnaissance, Abby. I think I've learned it today. That's one of them. So this one is another one. I've been trying to learn the actual pronunciation of that. So that is that. So they use that kind of wireless transmission, and then before we talk about choosing the right media, which media are we to connect these devices together in the network access layer? Which devices, which one should we choose? Should we choose copper? Should we choose fiber? Should we choose wireless transmission? So before we consider choosing the right media to connect these devices, there are 3 or 4 considerations. One of them will consider distance. With distance, as I already told you that fiber copper cables are majorly for what? Long distances. Then wireless transmission, you know that we are talking about short distances, and then they are prone to interruptions by anything that is wave, whether you are using microwave owning anything that kind of radio around them will interrupt them when you are using fiber, when you are using wireless transmission. Then copper is just for short kind of distance, not too long. So if I want to connect from Owerri to Lagos, for instance, or I want to connect from Ghana to Nigeria, what I'll use is the what is it called, the fiber optic cable. It runs underground the sea, and it will not be impacted by the kind of waves that is being generated in the sea. So because it uses light pulses, and due to the way underground generates electricity, so it will be affected when we are choosing the right kind of media to use. So be mindful of that, of the distance, which one covers. If you are using more like you just want to connect few offices, few upstairs, you can simply use that electrical one, the one that uses electrical signal. If you are talking about long distances, you can think about fiber optics. Then if you are talking about just being able to connect devices that don't can be connected in a wired connection, we talk about wireless transmission. So consider the distance, consider the environment. As I already told you, most of them are prone to some certain things, as I made mention of. So we also consider the speed. Some have high speed than the other. Something like copper fiber optic speed is much more higher because of long distance. It have to pass through a lot of things, so it needs to be in a high speed though. So consider them. Then consider the cost. Of course, sometimes cost limit us. Cost will make us to use one over the other. So those are the things that you put into consideration before you start choosing those media. Can we get a picture of those media? If there is any concern, please raise up your hand. If not, you can give me a thumbs up. All right, Bola, you can move further to let me show what those type of cables look like. But are you still with us? Okay, this is what the copper cables I was trying to talk about. As you can see, we can see the twisted pair copper cable. That doesn't mean we don't have types of copper cables, or we have different types. As you can see, you have the twisted pair copper cable. This is the one that you often see in a networking environment in your offices. You can see the coaxial cable. This is the one that you often use in your TV stations. This is the one that you use to connect your decoders, and then you can see the fiber optics. Then you can see the fiber, you can see the fiber optic, you can see the wireless. So under the copper, you can see we have twisted pair copper cable, we have coaxial copper cable, we have the those are the copper cables that we have. So the coaxial copper cable is often used in your decoders, as I said, and often used in television stations and all those things. But this type of twisted pair, you often see it in use. That's the core one that we normally use in our networking environment, trying to connect one system to another. If we are talking about larger systems or longer distances, we talk about the fiber optics. You can see how thin they are. They are used in wired connection. They can go underground. They cannot be easily impacted by any form of interference, unlike other ones that are here. So that's the depiction of the diagram I was trying to say. So can you move forward if there is no concerns? Okay, I want to explain two asset layer terminology that I think I made mention of when I was saying something encapsulation and then internet. So the Ethernet is a protocol that makes those things to happen. So that a network is set up and then messages are transferred using those MAC addresses, as I said, which are the unique addresses given to devices when they are manufactured. They hardly change. So it's the internet that conducts what happens within the network access layer. Why encapsulation? Why I need to talk about this is encapsulation is more of putting something in order to make that thing achievable. So in the sense of I'm trying to send a letter to somebody, I put it inside an envelope and just write the name. So I'm using that envelope as a kind of way mechanism to send that information. So the actual information is not lost. So once the person that gets the message gets it, what does he do? He removes the envelope and throws the envelope away and gets the letter. So the same way invariably happens in a network. So messages can be encapsulated to enable it to flow through the layers of communication that we have. So when we are sending something from application layer to something is going from the physical layer. So as they are going as switches, as lights and electrical signal, for them to go to the data link layer, they have to take another form. They have to be shielded. They have to be covered up. So as when it gets to that device, then that device will unwrap it. So that form of system whereby an information is put into another information in order to enable it to be transferred across a network for better communication or for better reach, we term it what? Encapsulation. So those are the network layer terminology that I think you should know to enable you to also understand what we are saying. Ethernet, the one that makes the access layer things to work. Then encapsulation, more like putting a message into another message for easier delivery and other purposes. So can we move forward? Is there any concerns? You can raise them up. If not, can we move forward? So this is a diagram that depicts what I'm trying to say. As you can see, this is the main data. This is the main data. This data has a header. So together, this data and the header is put together into one thing. But the actual thing a device needs is that data. But the header is an information that contains or tells us what to do. So in the sense of an envelope is not just the only thing, because that envelope has information that tells us how to treat that letter. So when the post office person reads the envelope, he knows the name and the address of the person is meant to deliver it to. So the same way also happens in encapsulation. Data is put into something. And as you can see there are two things that are existing here, the header and the data. That has to say the data and the header is encapsulated. So once the person gets the information, he reads the header and removes it, and then takes the actual data that it needs. There is the actual depiction of what I'm trying to say. In the envelope and letter thing, this is also what occurs in network, and it's called what? Encapsulation. So can we move forward? Can we move data? If they don't have concerns. This is still trying to say the same thing. This is still trying to say the same, trying to show us the IP4 header and every other thing. So during the encapsulation process, some other information is used to encrypt the data, to fold the data in, and then from there, the data can be sent. When the data is sent to the device that needs it, it will remove it, unstrip it, take the data, and utilize it for its purpose. I just want to tell us in this conclusion to brace up, brace up. There is nothing happening. Everything is going to flow smooth. The only thing you just have to pick up from all this thing that we have done is that there are standards that makes communication able, and this standard bring about the protocols and the rules that make communication able to happen. And then secondly is that there are layers that actually depicts or shows us how communication happen, and these protocols or these models have different forms. One tells us more of the protocols that make communication happen. The other one tells us the step-by-step layers that are obtainable for communication to get to the measure person. And then we are trying to address one of those layers in the TCP IP model, which is the access layer. We are talking about the cabling. We are talking about the connectivity, the physical connectivity of what those networks and what makes it able for them to communicate, which is the Ethernet technology. And I think that's a pretty nice one to go up with. If you can go home with their thing on network communication, protocols make network communication able to happen, then you can go home with their standards which tells us or enforces these things to be done so that devices can communicate. Then if you can go home, there are different models that helps us to depict how this communication happen, the TCP IP model and the OSI model, which are invariably called the protocol model and the reference model. So if you can go home with that, is enough for you to go home. And if you can also add more, like knowing the layers that are in the TCP IP model and knowing the layers that are in the OSI model, this is a pretty good one to go home with. So all the same, that's the little conclusion I have. I'm not even using what is on my slide. I'm so sorry. Should have been reading one by one, right? So if you have any concern, you can say anything. I'm willing to answer your question and address it. We still have 20 people on the call. That's a pretty good one. At least they were able to stay. So is there any concern or you all understood? Any concerns?
Yes, sir. Though I was
No.
following up until you skipped some parts, like some of your slides. You didn't explain it in depth. You
Which
just
which slide did I
summarized
skip?
the one before this conclusion.
Which one? Okay, that slide. I was just trying to say is the same thing on the encapsulation I was talking about.
Okay, but I saw time to leave.
Is that?
I think I saw time to leave. Like
There is no
I don't know.
problem. It won't be. So what I was trying to say is this. I was trying to expand more on the IPv4 header that was there. I was like doing encapsulation. Something is added to a message and the data that is put into that message. So that thing that is added to a message is more like a header. Header tells us what to do with the data that has been what encapsulated, that have been covered in. The same way envelope tells us what to do with the letter, that what is to do with what is inside the envelope, which is the letter. So that is what I was trying to say. Encapsulation in network is more like adding a header that kind of encapsulates the data. So somebody have to first of all open up that header to know or read something and then throw away the header because it doesn't do anything. It's just to help him to be able to know how to treat what the data that is contained inside that encapsulated message. So once he strips it, he takes up the header, takes the data and utilize it for their good. Though that's just what I was trying to see. That these are IPv4 header, these are what are they like. So they will tell you the version of the message you are receiving, the traffic class, tell you the payload length, that's the data length, tell you the next header, tells you the hop, tells you the source who is sending the information, and then you who is the destination address. So you can see that is what envelopes does for you. It gives you summary details of what to do. Then once you get the envelope, you read it, of course, then you throw it away because that's not what is your essence. Your essence is the word data. But the envelope was used as a means through which that thing is conveyed. That is what I was trying to explain with regards to the image. Are you with me, Stephanie? Is that what you said I skipped?
Yes, okay, thank you. Yes,
So,
sir.
all right, thank you. Is there any other person? It looks like today everybody is just understanding. It's good though. You have your concerns expressed. Do you know the difference between online courses? Do you know why you need this kind of live course? Let me just explain something. In online courses, you just take it hook and sinker. Like whatever that person says, you just take it that way. So you don't have any time to say, clarify me on this. And you were saying something last time ago. Now you are saying this. Which one is should we take? So in some kind of taking online courses. So if you don't have this kind of live courses that gives you a preamble, a good foundation to what we should thrive, where you meet or get so many online courses, you would surely be confused because there are so many resources out there online. So which one will you believe over which? And you don't even have a time to ask the instructor question. So this is an open platform. If you have concerns, express it. If you don't have, you can go and sleep. For those that want to sleep. Is that all? I've been looking for you since. Golden, where did you go to? I hope you took the test. You can say something.
Okay, good evening, sir.
Good
All
evening.
right. Yeah, I actually took it the first time we wrote it. I
Okay,
I
okay,
I, yeah, I dropped a chat that I used Opera Mini to log in, and then I was able to write the test.
okay,
Yes, sir. So my own is aside the question for today's class. Not
okay,
that I understood everything, yeah. So I just want to get the topic for last week because I joined late and I was kind of distracted. So we've not gotten the slides for last week class. So I just want to get the topic so that I can go ahead to read. And then secondly, I want to really plead with you people. now we are entering into the practical aspects of this program. If this recording can be shared after class, it will help us, most especially, I don't know for others. Please, like now the one for
Yes,
last week, I've not seen it.
yes,
Even the one
yes,
for last 2 weeks, I've not seen. Even recording now is another hot cake. We don't even see the recording of all these classes we have these days. And then for the slides, it takes time before it's coming. Please, I don't know if you can just just help us. I know it's not that easy. Please, I'll be pleading even on the group. I do plead for such, but it's not coming at the time we need it and everything. This record is very, very important. This is practical. You know. All right, that's what I want to
Peace.
say. Thank you so much.
Okay, thank you. Peace, are
okay,
you on the
sir,
call?
sir, please, I
First,
just
you
want
want
to
to say
ask
that?
you. Yes,
All
I
right,
want
go
to say,
ahead.
I also want to say, I don't know if each of those topics we treated right from the beginning can be placed on the group because I really started late with two people. I don't know if it can just be placed on the group based on the topic we treated and also with the recording. If they can paste it on the group before they paste it on the YouTube, I don't know if it's possible.
Okay. Peace, are you with them? Because I don't have any access to the recordings, and then I share my slide with her. She's the one to the peace. Are you on the call? She's not on the call. That's the person that you have to address to when it comes to everything pertaining to recording and then your slides, because once I'm done I send it over to her. I don't have access to those things. I don't have access. My own is to get on board on the call and then have sessions with you. So she's the one in charge of your classes and she's still part of your program, I guess. So she's the admin or whatever it's called, or the representative. So about that. So she will be then. I think the recordings, as they said, all the recordings is in the YouTube. Then for my slide, unless I'm not done teaching the slide, but all my slide, this is the last one that I remain I have not sent. I will send in the
Okay, so
slide to her.
sorry to cut you, sir. We've not received slides for Tuesday class. It was Saturday when we received. We've not received slides for Tuesday class, and then this one now. So the recordings you just mentioned now, I've been checking YouTube. I've not been seeing even security audits. I've not seen the this thing up to today. The recordings. I mean the record rather. So other recordings after that I've not seen. Please just help us check it and find out what I'm saying. I don't know if others too, whether I'm saying the right, whether they've seen their own and I'm not the one seeing it. I don't know, but I'll be checking and I've not been seeing.
The people should query Faith online, no, because I used to also tell her, she would say that it's already using the YouTube thing platform. That's your representative when it comes to anything pertaining to these classes. But still, I'll try my best to reach out to her to know what's the challenge. But I know all my slide, I do send them. Any slide I'm done teaching, I'll send it to her. This is the only slide I remember. The Tuesday slide have been shared, and the Tuesday slide was this slide. Okay, the Tuesday slide was this slide. I just did a part of it and then did the what was it called again? What happened on Tuesday? What happened on Tuesday? I don't remember what happened on Tuesday. What
Network,
happened?
network design. I think
Okay, network disturbed us, right? Okay, that's true. I was doing practical, yes, and I said I will finish up the practical. Then I did half of this slide on that last week. Yeah, I did half of the slide and did half of the practical. Then today I finished the practical and also finished the slide. So immediately I'm done now. The slide is ready. All my slides is ready. Even for future classes, they are ready. So immediately I'm done now. I'm going to send it to all my slide. I've prepared them is there. So I prepared them beforehand because I'm still handling some other things. So that it will not be any obstruction. So if you need, once I'm done with this, as I'm finishing this class, I'm dropping it with her. Even there, Bola, you are with the slide now. So you can, this is the PDF now. Bola is with the slide. So that's to tell you I prepare my slide before. I'll still drop it with her so she can share with you guys. So that's on that. Then for the recording, I will still ensure that I talk to her about that. That's what I will do. I'll talk to her on that about that. So she will take other, but she's the person to address any of your concerns to. But anything pertaining to my slide and lecturing, address it to me. But I will still have to talk to her about it. So that's that. Is that all?
So what about the topic so far? Like you also said something about topic and me and two talking about it.
You said?
Like the topic, like each topic that is treated, if they can just paste it on the group so that we can work with that if we did not see what we are looking for.
Okay, the topics. The topics are based on how the slides have been shared. So if you just go to the first slide that was shared, I don't know how these things were organized. They should have brought out a particular group where they would just be dropping slides and recordings. So each topic with the slide and recording, each topic, so that that group should be locked. Nobody should be chatting on it. It should be closed. So once anybody goes there, they can be able to peruse through everything. But I'll still make those suggestions to peace and see how possible it will be to do such a thing so that you can reference back to everything. So, as I said, I don't
Yes, I
have
will do.
much thing. It's just to talk. I'm not in charge of the program, so the TFM is the one in charge. So they just have to call and answer the call. So I will talk to her, so they will do something about it, hopefully. So that's on that. So is there any other thing? Or we can call it a day. Is there any other thing? We can call it a day, right? If you can call it a day, thumbs up, please. Okay, thank you very much for being part of this journey. Thank you for tuning in today. Thank you for following up. Thank you for trying to understand. Thank you for being knowledgeable all this, right? I pray that your good endeavors will actually yield this fruit in due time. Thank you. Do have a blessed night. God bless you. All right, Bala, you can stop the recording and then. All right.